In problem 32 here, we are still looking at the time that a fully charged cell phone battery lasts. Our mean time is 10.3. Our standard deviation is 1.2. We're using the calculator to find the following to 2 decimal places. The 15th percentile of time that a battery lasts. So 15th percentile is the value with 15% of the data below it. So here's our bell-shaped curve. 10.3 is in the middle. That's our mean, 50th percentile. So the 15th percentile is somewhere to the left of that. So we want the x value here, time is our x value, where this area here is 0.15. So left area is 0.15. So we're given an area, we want to find an x, that's inverse norm. So we want to do inverse norm. And we put in our left area of 0.15. And then our mean of 10.3, and our standard deviation of 1.2. So in the calculator, second variables, inverse norm is 3, our left area 0.15, mean 10.3, standard deviation 1.2. And if you have the menu, you want to set it on left. If you don't have the menu, it's automatically left. 9.06 to 2 decimal places. So this x here is 9.06 hours, is the 15th percentile. So only 15% of the batteries will last 9.06 hours or less. Find the 40th percentile. So that's saying 40% of the area is below that value. Well, again, 10.3 is at the 50th percentile, 50% to the left. So whatever that value is, it's a little bit to the left of 10.3. So this area is 0.40, left area. So instead of 0.15, we want 0.40 inside of inverse norm. 10.3 and 1.2 stay the same. Let's go to the calculator. Second variables, inverse norms number 3. We just have to change the 0.15 to 0.40. And 10.3, 1.2 stay the same. We are using left area because percentile is below. It's left-tailed. 9.995, 9.9, that's going to round up to 10.00. 9.9959. So to 2 decimal places, 10.00 hours. So 10 is the 40th percentile. Find the first quartile of time. So first quartile is 25th percentile. So that's going to be 25% of the area to the left. So similar to what we did above, except it's 0.25 is our left area. 10.3, 1.2 still stay the same. So that 25th percentile then is going to be second variables, number 3. Change the 0.40 to 0.25. 9.49. So 9.49 hours has 25% of the data to the left. How long do the top 10% of the batteries last? So top 10% is saying 10% are above that value. So 10.3 in the middle. And we've got some time over here, x, where 10% are above. So that area right there is 0.10. Now, if you don't have the menu, you need left area. Well, 1 minus 0.10 is 0.90. So that's this calculation here. That's the left area. So now we can do the top 10% is the same as the 90th percentile. So inverse norm, 0.90, 10.3, and 1.2. Second variables. Number 3, change that 0.25 to 0.90. 11.84. So over here, 11.84 hours, only 10% of the values are above that. That's top 10%. Same as 90th percentile. Now, if you have the menu, then you could put the 0.10 in there and then just use right tail, since top 10% is 10% or above. And we get that same 11.84.